have reviewed a problem, and now we're taking the idea of Snell's law and looking at another aspect that we can glean from it. So, what I was wondering, and I'm sure you were as well, if we're going from glass to air and the index of refraction is 1.5, I was wondering when this happens. It turns out, I'm going to draw this lightly because it's not the angle the light beam I'm really interested in. I know if it's going from glass to air, it's going to refract. It's going to be at a different angle. I'll make it, see this one's going from, it's going to refract, and then if I draw it at a, let me switch colors, that always helps. So I'm going to take another beam in, and it's going to be at a lower angle, or a higher angle of incidence, closer to the actual border here, and it's going to refract at some place. Then I'm going to take a lower one, and it's going to refract. So eventually, at a certain angle, one of these is no longer going to refract, it's going to reflect. So it's not going to refract anymore, it's going to reflect. And we're actually going to have to figure that angle out in lab. So I wanted to show you a problem like that. And the question here is, I want you to, we know Snell's law, n1 sine of theta 1 equals n2 sine of theta 2. And I want to know what angle does this have to be for this to happen, this orange to happen, the reflection instead of refraction. So, and that's all the problem tells you, so that kind of leaves you hanging. So I'll give you a push mathematically so you can see what happens. Alright, so let's find out what angle, if we're going from glass to air, we know that this is glass, this is a 1, so we're happy with that. And we know that this is in glass, so it's 1.5, so we can set that much up, but it's the angles that we don't know enough about. So let's solve this for sine of theta 2. So mathematicians, take the numbers I've given you and get sine of theta 2 all by itself. Alright. Not hard to do because there's only a 1 sitting next to it. I kind of dropped it when I divided both sides by 1. I didn't even let it show up. So now I want you to take that and solve it for sine of theta 1. Because that's the angle I'm asking for. What is this angle right there that will cause a reflection instead of refraction? So get sine of theta 1 by itself. Now, I want you to recognize that this number over here must always be greater than 1 when it is here. I'm sorry, we should have made note of that right there. When we studied the sine curve in math class, remember it? It goes up to 1 and down to minus 1 at all times, right? Up and down and up and down. So, I can take this, because I know this number can never be greater than 1. So I'm going to go back to here. You can save that right here. Let me use this. Since sine of theta 1, this turned out to be sine of theta by itself, it's got to be greater than 1. 1.5 times sine of theta 1 has to be greater than 1. So now take that and divide both sides by 1.5. What's 1 divided by 1.5? I didn't finish this discussion, so you'll have to help me. What is 1 divided by 1.5? Alex?
It is 0.6. You want a fraction or decimal?
Decimal.
Okay, 0.67.
All right. So when does that happen? When does that ever happen? Now your calculator has to come out and tell you what angle, let's do equals 0.67, because then we'll know any angle greater than that will be greater than 0.67. So how do we find an angle in our calculator that has this as its sign? What button will we use?
Inverse sign.
Pardon?
Inverse sign.
Inverse sign. So let's do an inverse sign of 0.67, and that will be, can you get that for me, M?
42.
42. So it turns out, for this angle to be greater than 0.67, it has to be greater than 42. That is the answer to this question. So when this angle, this orange light beam, I drew it way off because I didn't know what the answer was going to be. But when that light beam is greater than 42 from this perpendicular, it will no longer refract, it will reflect. All right, so we'll actually go through that again during lab. So if you could just put those questions on hold, and yeah.
Did you say, so the sign of it has to be greater than 1 or less than 1?
All right, okay, actually, you're right, I didn't make that clear. This is normally greater than 1. So for this refraction to happen, this would have to be less than 1, but we're trying to find where it is impossible. So I switched it to greater than 1 and didn't even explain why.
Okay.
All right, so this is where it's an impossibility, where Snell's will not work. It will not refract, it will reflect. And I actually got to walk you through that in lab, but I wanted you to see it once in class. All right, you can smell Snell for the last time right now and put him away. And we'll start.
Smells whack.
One more topic left in this mod, but several labs, so we have a couple days. Well, we've been going about 5 or 8 minutes. What do you
Copy
think?
that down there, kid. And everything. Should be here right now.
All right.
Better be at school tomorrow. I'll kill you. Disappointed. Lots of hope in you.
All right, we can now start a new segment just because we're starting a new
Make commercial break,
topic,
be right
so
back.
tell me when.